many of which have got direct experience with the tool and mold making industry. 22 years of our software company has been focused on the tooling industry and providing specific solutions to the needs of die makers, mold makers, and the like of that. 2,500 customers worldwide are used specifically for tool making, and we are found operating in 35 countries around the world. Now, what we're going to talk about today is automating the electrode process, and for many mold makers, it's part they don't like. It's a necessary cost toward getting the mold out the door. What we hope to look at is seeing how that electrode process, the manufacturing and design of it, can be cut as much as 50%. We'll see some of the practices that are available out there and how their solution can be provided that makes electrode making easy and quick. Plus, it's an easy solution. Cimatron supports the process. We've got web-based support where we can log right onto your computer and help you and assist you in learning the process and putting it to application, so that in the end, hopefully electrodes won't be the hated part of mold making, but you'll find to be economical and enjoy doing it. Now, some things that we have found, have investigated the industry to understand the electrode process. We found that 34% of your typical mold build is devoted toward designing, manufacturing the electrode, so it's a significant part of mold making. On the average, that boils down to about 38 hours a week for a typical shop is spent just on electrodes. Some of our customers that we pulled, that average goes up to as much as 200 hours a week in some of the bigger shops. So we can see the man hours that's involved in designing and making electrodes. We boil that down into some costs. There are a couple of theories about how to do that. Some would prefer to have the mold designer do it because he has the most of the tool as he's designed it. He knows the tight areas, the area that would need an electrode, and that on average boils down to about $75 an hour. Whereas another school of thought is to have the NC guy do it. He knows what he can cut and what he can't cut. So what he can't cut, he design an electrode for. And that's still not cheap. That's $61 an hour. So you've got two very high-end individuals tied up with these electrodes, and it's a costly process. 63% say they are documenting their electrodes, putting it in drawings, creating spreadsheets to order the 7 don't even do that. And the timing is an issue. That electrode has to get manufactured and be applied to the job as soon as it can. Often the first one is being burnt before it's even designed. So it's an ongoing concurrent kind of process. And while 63% are actually documenting the electrode, it's an automatic process. They have to fill those spreadsheets out by hand or create those drawings and those views individually. And what that can happen is an error, and the of error when making and using an electrode is human error. And that's really admitted by some really, really good electrode manufacturing. Not to say that there aren't good people involved here, but it's a flaw in the process. If you have to manually write down the numbers for your electrodes, or if you have to manually type in your burn locations at the machine, right away there could be a cause for error. And on the poll, 69% say that making the electrode is critical to getting the mold out the door on time. We're talking about a very significant part of the mold making process, and hopefully what we can show you today will give you some ideas on how to better go about doing it and some solutions that are available in manufacturing your electrodes. So starting Cimatron, we're going to load up a job where we're going to pull some electrodes. I'm going to take a simple core or insert out of a mold. And something to look at just briefly is the ability to set up standards, such as how much do I want the graphite to green tip, or the overall graphite size, how much clearance do I want to have extended beyond the top mold surface, how do I want my drawings to look. All this can be standardized ahead of time so that there's then in the electrode making process. Of course, with each job you may have unique needs, and that can be accommodated as we go through manufacturing it. So looking at the part, you can see it has got some nice burn areas where I've got bosses to deal with. I've got ribs, crisscrossing ribs that need electrodes applied. And we use the wizard over here on the right to pull these. So first let's start on this lower right corner. for the first electrode. It pulls up the graphite size. Everything that's fully enclosed within that blue box gets grabbed as a burn surface. The overall length and width can be controlled right here off of the chart. You can see it's already locating the X and Y burn position. Some other tools available that you can work with are an automatic centering, which now forces it to center, and a function that fits it, which will bring it into a graphite size that has already been predetermined, much like a catalog or library size for graphite. We'll work with what we have here as our burn, start creating an electrode from it. Showing just that area on the screen, we can see what we're working with. We'll pull up the blank. See, these values have already been pulled from our preferences, so those are the overall values to begin with, but you can easily change them on the fly. Kicks in to show you the results of the change as you're creating it. That looks good. We'll go ahead and work with that. Now we're going to tell the system where we want to pick the electrode up for our zero location. It can be on the back of on the clearance plane, on the burn tip, any of the four corners of those locations, or a point that you yourself would like to determine to be the pickup point. We'll sweep along the outside edge of our surfaces now because we want to create extensions. A common practice that many use is to let the cutter waterfall off that burn area. But if the nice tangent extension were possible to be placed there, lead edge in the burn. Nice tools have been developed to do just that. Such as you see, I'll go a tangent all the way around. You can see what that looks like, a good 100,000 band of tangents. The other option is to drive it in a specific direction, so that's what it would look like pulled straight up in Z. The option I'll use here is to drive it tangent in two directions, so get a nice looking square corner. Let's say we go 50 thousandths up, 50 thousandths out the side, and then we'll close that side off with filling surface. So there I've got my first extension built. Automatically we start building the next one. Drive it straight, maybe take it all the way to the blank. While we're doing that, we can add a step to it, a bit to 50 thousandths, and when we execute it, you can see the completed electrode now. So just that quickly and easily, we pulled out some options that are nice to look at too that I haven't showed you yet. On the blank itself, so there's the completed electrode. Now some nice options that are available, if I go back here and edit the blank, that blank is pulled off of there. For instance, many customers need to put a step around that blank edge like you see here so that they have a good squared surface that they can pick up the dead center with. Condition where the shape of the base is important because you need to have maximum strength. So a shape base like you see here steps around the mold surface and clears it so that you get maximum strength in an area. So two other very nice options for creating this electrode. Now we like what we see on the screen here, so we're going to save this methodology of creating it. It's called internal to our system. I'll call this one Trode 1, and we will save how we created this electrode. Let's use that in applying it to our, going back to our mold surface here. We'll go over to the other corner here off on the right hand side and pull an electrode from there. Again, dynamically, you can size out your electrode. You can specifically type in the values. Additional surfaces can easily be removed. We'll force that to center and then tell the system that's what we're going to work with. Now I've got two electrodes over on my tree. Working with this one, zoom out a bit, we will apply a template. Here's the template we just made with a nice pretty picture to remind us of what we did. And it applies the exact analogy as the first template, or first electrode. So with a library of templates, it can be very easy to quickly automate different styles, different ways that you may create those extensions, different sizes that you may use. At this point, with that electrode done, perhaps I have to worry about engineering. I can't wait to pull all the electrodes from this job before I begin manufacturing them. we'll take this electrode and send this off to NC. Tell the system where we're going to cut from, and then just as there is a template to create the electrode itself, there is also a template to machine it. So here, saved in my directory, I've got a template that will grab those surfaces automatically, box around that, and just begin to manufacture it for me. So we kick this off, and there you can see it beginning to build up the G code. All right. So that goes on while back here I can be in my main file pulling more electrodes. So concurrent engineering is a big part of this solution. Meanwhile, the electrode can also be documented. Still in this electrode, I'm going to go and grab a holder. The holder can be anything of your choosing. In the system, we've got some Aurora holders already built. If you have a system for holding the electrodes, you can use that. Automatically, it'll place it on the back of the graphite for me like you see here. We'll take that electrode that we worked with and now send it off to a drawing. So while it's being programmed in Cimatron, we're documenting it right now, where the burn location is going to go, what the overall sizes are that this electrode needs to be burnt or built to. Looking at the drawing, again, you can see the files that we're creating as we're working. That drawing is created automatically like you see here. Down at the bottom, we've got a burn location chart. In the plan view, you can see it in location of the tool. Over on the left, there's again center of tool with all the overall dimensions nicely displayed. Overall height view up here, likewise showing the center location. Zooming up on this chart, you can see information for the burn location, the overall size of the blank, and also filled in yet, the spark gap, the orbit value. All that is information that's going to be assigned to the machine that we're going to use to burn with. So once we set up that machine, these fields will automatically fill in for us. Going back over to our main file, let's pull some more electrodes. So let's look at that rib area that we're going to deal with next. Ribs, let's build the first one and apply a template to the second one. Again, I've got my blue box.